Math 1314, Tyler Junior College, Section 2.1, Basics of Functions and Their Graphs. In this final video of the series, we're going to obtain information from a graph. So far in this video series, we've defined a relation, a domain, a range. We've identified domain and range from a set of ordered pairs. We've defined a function and asked the question, is this relation a function? We have looked at relations and functions as equations, since equations imply a set of ordered pairs. We've answered the question, is this equation a function? We have looked at function notation, both functions of x, and for those who are paying attention to the calculus commentary, functions of y. We've graphed a function by plotting points, both functions of x and, from the calculus side, functions of y. We answered the question, does this graph represent a function, by using the vertical line test. And for those watching the calculus portions, we also answered the question, is this graph a function of y, using the horizontal line test. So the last thing we're going to do is just pull a bunch of information from a graph. Since a graph technically represents a relation, because each point on the graph implies ordered pairs, it's legitimate to ask what is the domain and range implied by this graph. And if that graph also happens to be a function, it's fair game to ask questions like what's f of -3, or what values make f of x equal to 6. And we're also going to look at something we haven't looked at yet, intercepts, but those are pretty easy. So let's start with this first graph, which is made up of 2 line segments and then a ray, if you want to be geometrically correct. This graph begins out of nowhere at -7, 11, goes through the point -5, 6, and then bottoms out at the point -3, 1, at which point the graph starts to increase until it goes through the point 0, 4 on the y-axis up to the point 2, 6. At that point, it makes a sharp turn downward, crosses the x-axis at 5, 0, and continues that direction indefinitely. What information can we extract from this graph? The answer is a lot of it, even more than I've put here, but it's beyond what we've discussed so far. So let's start with f of -3. How can we use a graph to answer a function question? Well, recall that when you're doing a function of x, and from this point forward they will all be functions of x, that the input represents an x value and the output represents a y value. So in any function problem, the number that you put in is the x, and the number that comes out is the y. If we're being asked to find f of -3, we're being asked what y is paired with an x of -3. So for this problem, we have to look on the graph for a point of the form -3, something. And if it's a function, there should only be one of them. Do you see it? It's this point. Because this point on the graph is -3, 1, that means as a function problem, 1 would be the output when -3 is the input. And so the answer to f of -3 is 1. We can quickly rattle off several function problems. For example, what is f of 2? That's like asking what is the output when the input is 2, which is like asking what is the y-coordinate when the x-coordinate is 2, and the answer is 6. And we can actually ask that for any point whose coordinates we know. Let's look at the second one that says solve f of x equals 6. Again, if we think of this in terms of inputs and outputs, and x's and y's, we just have to look on the graph for the correct ordered pairs. So what are we looking for? Well, in this particular problem, we don't know what the input is, that's what we're solving for, but we do know the output is 6. So we're looking for points on the graph whose second coordinate is 6. And there are 2 of them. Here's one, -5, 6, and here's another, 2, 6. So according to this graph, there are 2 x's as inputs that would produce an output of 6. The first x is -5, and the second x is +2. -5, 6, +2, 6. So both of these are what I affectionately call ungraphing. Graphing a function means you put numbers in, you get numbers out, you make the pair and you plot them. Ungraphing is the pairs are already plotted, you pull them off, and then interpret them in the context of a function. As far as domain and range go, you might think it's pretty easy. I know how to do this. Domain is x's, range is y's. So, the domain is -7, -5, -3, 0, 2, and 5. And you would be wrong. Well, you're not wrong in the sense that those numbers aren't in the domain. They are, but there are many, 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 many more numbers that are not listed explicitly. The 6 numbers, the 6 x's for the 6 pairs that are labeled are precisely that. Only 6 pairs. How many points are on this graph? Well, everywhere I can put a dot, there's a point. And I can fit an infinite number of them on this graph. So there's no way I'm going to be able to just list all the x coordinates because A, there are too many of them, and B, they are so densely packed that I couldn't even list them in order if I needed to. No matter what 2 I write down, I can fit another one in between. So how can we describe the domain? Well, we're not going to describe it by listing a set of numbers in set notation, first number, comma, second number, comma, third number, etc. We need to think about these x values collectively. And in order to do that, imagine smashing this graph down to the x-axis. Now, what do I mean by that? Well, let's take this point 2, comma, 6. The only thing we're interested in is its x-coordinate. And if we were to project that point all the way down to the x-axis, flatten it down, it would land at x equals 2. Or this point back here at -7, comma, 11, if we projected it straight down, it would land at -7. So imagine where all these points would land if we flatten them down, and equivalently, all these points on the right if we projected them up. So if you can imagine compressing the graph to the x-axis, then the domain is the part of the x-axis that would be covered by that graph. Another way of thinking about it is imagining that this is a 2-dimensional picture, but you're standing above it looking downwards. There would be no width because it's only 2 dimensionals, so all you would see is the x-axis covered by part of the graph. So how can we figure out which part of the x-axis is covered by the graph? Well, think left to right. The leftmost part of the x-axis covered by this graph starts at -7. And that is part of the domain. Every point afterwards is also included. For example, everything between -7 and -3 would land here, everything between -3 and 2 would land here, and everything from 2 to infinity would cover the rest of it. So everything on the x-axis starting at -7 and going to the right forever would be covered by the graph if we collapsed it to the x-axis. Well, this looks like an interval because it is. So from left to right, the domain begins at -7, and it includes -7 because that is part of the graph. So we're going to start an interval at -7 with a bracket, and it goes forever to the right. So comma infinity. So the domain is every real number -7 and greater. For the range, we can kind of think the same thing. Range is y values, but it's not just these y values. It's every y value for every point on the graph. Well, let's think about how we would locate the range. For this point up top, -7, comma 11, its y value is 11. For this point, 2, comma 6, its y value is 6. In fact, which part of the y-axis would be covered? But this time, instead of projecting the graph to the x-axis, we'll project it to the y-axis. In other words, we're going to collapse this graph to the y-axis. So if everything over here got pushed to the y-axis and everything over here got pushed, what would be covered? Answer, everything from 11 below. It doesn't matter where you stop on the part I'm shading in, it is in the range. For example, if I pick 4 is right here. If I pick 3, is that in the range? Is there a point whose y-coordinate is 3? Yes, there are 3 of them. One over here, one here, and one further to the left. But everything from 11 downward would get covered by the graph, and it would go forever down because the right end goes forever down. So what is the range? The interval representing what's covered. But remember, intervals are always least to greatest. So we're not going to start with 11, we're going to end with 11. So this range starts at negative infinity, goes all the way up to 11, and includes the 11 because the point that the 11 came from is part of the graph. You can tell because it's filled in. If it were empty, it would not be part of the graph, and the 11 would get a parentheses. For the intercepts, this is easy. X-intercept is the value where the graph crosses the x-axis. That's over here at 5. And the y-intercept is the value where the graph crosses the y-axis, and that's up here at 4. So obtaining information from a graph is pretty straightforward if you remember the relationship between function notation problems and ordered pairs. X goes in, y comes out. The way to determine the domain and range by collapsing the graph to either the x-axis or the y-axis. And then the x and y-intercepts are just where you cross the x and y-axis. I invite you to pause the video and see if you can come up with the same types of questions or answers for these. I will warn you that the first two, I'm kind of setting you up. Okay, either you paused or you didn't, but either way, here we go. Let's start with f of 2. In order to evaluate f of 2, I need to find an ordered pair whose x is 2. In other words, I need to look for 2 comma 0. Excuse me, not 2 comma 0, 2 comma something. That's what I'm asking for. What's the output? Good luck finding a point on this graph whose x-coordinate is 2. Why? This graph shuts down at -4 and it's just gone until 4. 2 is over here, halfway between 0 and 4. So to look for a point whose x-coordinate is 2, I have to go over 2 and then look up or down until I see the graph. I see no graph here. There is no point on this graph whose x-coordinate is 2, which means that f of 2 is undefined. There is no point above, below, or on 2 on the x-axis to have a y value as an output. What about solve f of x equals -1? Well, now that I kind of let you in on things are going funky here, maybe you can figure out that this has no solution. Because if I go down to -1, well, let me back up. What am I looking for? If the output is -1, that means I'm looking for an ordered pair whose y-coordinate is -1. But if there were an ordered pair whose y-coordinate is -1, it would be down here somewhere. And this graph does not reach that far down. Since there is no ordered pair whose y-coordinate is -1, this equation has no solution. Let's erase the part that's in the way. So that was kind of sneaky, but it is a possibility. There are such things as graphs that are disconnected or pieces that don't have solutions. Like back on this one, you couldn't figure out f of -10, the graph only goes back to -7. Or you couldn't solve f of x equals 20 because the graph doesn't go up to 20, it only goes up to 11. So let's talk about the domain. Again, the domain are the x values, and so the x values are what we would get if we collapsed this graph down to the x-axis. This left branch, if we smushed it down to the x-axis, would be everything to the left of -4. Now, I know I said pause the video and try to answer these. I'm going to make a minor change before we move forward. I'm not going to change a question. I'm going to slightly alter the graph to make a point, which is ironic because I'm going to make a point by taking away a point. I'm going to go over here to 4 comma 0, erase the dots there and replace it with an empty dot, meaning that the dot is not there, but this is the boundary of the graph. So it comes in to that point, but the point is empty. This one is still full at -4 comma 0. Okay, so we're finding the domain, so we're collapsing the graph or projecting the graph down to the x-axis. And if we do the same thing over here, I meant to draw these, just imagine flattening this straight down. And if we flatten this straight down to the x-axis, everything to the right of 4 would be colored in by the graph, except at 4 itself because it's empty. So as an interval, we'll need 2 intervals because we have 2 portions of the x-axis shaded in. The interval on the left, remember intervals always go left to right, negative infinity to negative 4. But is negative 4 part of the domain? Is the circle whose is the point whose x-coordinate is negative 4 filled in? Yes. So we include the negative 4 with a bracket. Union, the interval for this portion of the x-axis, which starts at 4, x equals 4, and goes to infinity. But is the 4 included? No. The point whose x-coordinate is 4 is empty, and therefore we do not include that x in our domain, so we have to put a parenthesis on that 4. General rule of thumb, if you're doing domain and range on a graph, and an endpoint is empty, it gets a parenthesis. If it's filled in, it gets a bracket. Let's talk about the range. The range, being the y-coordinates, is what you would get if you collapse the graph to the y-axis. So let's imagine there's 2 walls, like in the first episode 4 of Star Wars and the trash compactor, where the walls start coming in and we're squishing the graph to the y-axis. The left end of the graph would get compressed, or projected, I should say, onto the y-axis. The right side of the graph would also get projected onto the y-axis. So swoosh, and what would get covered with the graph? Well, first off, would the origin be included? Would 0 be included? Is there a point on the graph that would fill in that? Equivalently, is there a point on the graph whose y-coordinate is 0? Well, this one isn't on the graph because it's open, but this one is. So this filled-in point would get projected all the way to the origin, and everything above that would be as well. Well, or would it? Is it going to go up forever? If you see a graph with arrows and no line saying don't cross me, we will see those later, then the presumption is it will continue to go up forever. It may go slowly, but steadily up forever. Since range is y values, since we're looking for an interval, we go from least to greatest. And on the y-axis, least to greatest means bottom to top. So the lowest y value is 0. It goes up forever. And because this point was filled in, 0 is part of the range, so we have a bracket. By the way, if this point were empty, then this point would be empty also, because the other point wouldn't have filled it in. X-intercepts, where this graph crosses the x-axis, or touches the x-axis. There's a more rigorous definition of an x-intercept. It's a point on a graph whose y-coordinate is 0. This point's y-coordinate is 0, so negative 4 is an x-intercept. But is positive 4? No, this point is not here. It serves as a boundary, but it's not part of the graph. So negative 4 is the only x-intercept. Are there any y-intercepts? Does this graph touch the y-axis? It does not. It goes down to the x-axis and then it just jumps over here and then it continues. So there's no y-intercept. So as you can tell, there's a lot of information you can extract from a graph, especially if you know the coordinates of several points. Function values, inputs and outputs, domains, ranges, intercepts, it's all good. Oh my goodness, that was a long video. My apologies.